All right, welcome back. This is Unit 5, and in Unit 5 we're talking about ionic bonding. And I'm Mr. Forster, and this is Mr. Arthur again, and we're going to talk a little bit about the why or what elements participate in ionic bonding.
So what is chemical bonding to begin with? And this is just really, we've talked about, we spent this entire unit looking at how these electrons are arranged.
Right.
Because that's kind of the whole key in why elements bond together is the arrangement of their electrons. And basically electrical attraction between these different atoms.
This is
those valence electrons that you looked at on the Bohr models, on the orbital diagrams, on the electron configurations. Those valence electrons are what occurs bonding to occur.
Right.
And so we've talked about the octet rule down there. They should be familiar with that. That you can only have, or you can only have a maximum of 8 electrons in the outer level. But that's what every element wants to have.
Correct.
When it bonds, its goal is to get 8 electrons in its outer level, or it wants to fulfill the octet rule, because that makes it stable, and that makes the atom content, if you will.
Yeah, it wants 8 electrons in its outer energy level.
Okay, so you want to go over a couple types of chemical bonding, or we're really just going over ionic?
Right. So we're going to talk about the other type of chemical bonding next unit. However, we're dealing with ionic bonding, which, like Coach Arthur just said, it deals with an electrical attraction. So we have pluses and minuses. Okay, so much like we have protons and electrons, we're dealing with positive and negative elements this time. So to become positive or negative, an element has to either lose or gain something. And the easiest particle for a atom to lose would be its electrons. Why do you think that is, Coach Arthur?
Well, they're farther out.
Right. We have the protons and the neutrons in the nucleus, and the electrons are outside the nucleus.
Well, and also, if we change the number of protons, well, that's changing the atom itself. So we're not. We can't change the number of protons. So we got to keep the atom the same.
Yeah, changing the protons changes the element. So a positive, to become positive, or what's called a cation, it has to lose an electron, or 1 or 2 or 3.
Why is losing an electron making it positive?
That's a good question. That's because, remember what electrons' charges are. Remember, electrons are negative. So if I lose a negative, my atom becomes positive.
So it's kind of like in math when you subtract a negative.
Yes.
Like minus a negative becomes
positive. Yes. And much the same, if I gain an electron, I become my name for the atom is an anion, and I gain a negative charge.
So I have more negative charges. My atom becomes negative.
Now,
in ionic bonding, it's important to know electrons are not shared.
Right, they're not shared.
They are, and the word we'll probably use is transfer.
Transfer.
These electrons are transferred from one atom to another. Okay, so if 2 atoms bond, one atom is going to transfer or give away their outer shell electrons. Another atom is going to take it on. And again, we're going to get to covalent bonding in Unit 6. This whole unit is just on ionic bonding there. So how ionic bonding works, we've got 2 or more ions. To begin with, we'll just start with 2 ions, but then we'll work our way to 3. But they form an electrically neutral compound. So a cation and an anion form a neutral compound, and neutral is important.
Neutral.
Because in every compound that we form, in every compound we look at and write the formulas for, it's got to be neutral. And so this is kind of just a review down here of what we talked about on the last slide, but there's an atom that's going to give away a valence electron, and that atom's going to become positive. There's an atom that's going to gain or take on an electron, and it will become negative again because those electrons are negatively charged. So it's going to become negative. And then the negatively and positively charged ions are attracted to each other just like a magnet.
Right.
You've got a positive, you've got a negative. And just like a magnet, those things are going to
come together.
Attract. Also, ionic bonding, just to show you remember, are a combination of a metal and a non-metal.
Right. So
not going to have 2 non-metals, not going to have 2 metals, but they're a metal and a non-metal.
Right. So metals, remember, are on the left side of the periodic table, and non-metals are on the right.
So, Coach Forster, this is here just so we can go over what's called oxidation numbers. We want to know how do the elements, how do they get their charges? So let's draw in those, at least the main columns that we know of the oxidation numbers.
Right. So the ones you're going to have to remember, and I would label this on your periodic table, and it's much the same as the column numbers on the table. So these atoms, metals always tend to form cations, so they always tend to be positive. So this first category here we call the alkali metals, first group. Those are always going to be a +1 charge. Okay, so they're always going to lose 1 electron. All right, the next group, the alkaline earth metals, are always going to lose 2 electrons, so they become a +2. All right, we're going to kind of skip this region in the middle, the transitions.
We'll learn about that as we go. We'll do some examples of that as we go. There's a different way to do that.
Right, there's no set rule for transitions, though. We'll skip that, and this column will always be a +3. All right, this column can be either a +4 or a -4. Okay, because it's kind of the transition between metals and nonmetals, and then we get to the negatives. Okay, this column is the nonmetal starts a majority of the nonmetals. Those are always going to be -3. These are always going to be -2. This column, the halogens, are always going to be -1. And then the noble gases really don't want to lose or gain anything.
They already have 8 electrons in their outer level.
They all have 8 there.
That's why they don't
so
bond with anything. That's why they don't react with anything, really.
Right. So these are the main groups.
So when those elements bond, those are the charges they take on. When we write formulas, those are the charges we'll look up for each of those elements.
Right.
Okay, so how the metals, we're going to look at how the metals react and then how the nonmetals react in a bond. And so the metals, again, they're the cation. They're the positively charged, the left side of the periodic table that we just drew. And they're going to have either 1, 2, or 3 valence electrons, outer shell electrons, that they are going to use in bonding.
Right.
And so it's very easy to lose these. This is an example of sodium down here. And you can see sodium just has 1 electron in its outer level.
Right.
10 electrons are in the inner levels. But then you've got 1 electron in that outer level. But for sodium to bond, it's going to lose that 1 electron to some other negatively charged now element. And sodium makes a positively charged ion with 8 electrons in its outer level.
Right.
That it is now very stable.
Right. It gave away 1, so it could have a stable configuration.
And so then we come to the nonmetals. Is just the opposite. These are the ones that are going to become anions or have a negative charge. Okay, and they're going to have 4 or more valence electrons. So the easier thing for them to do is to pick up electrons. They're closer to 8 by picking up. Sodium was closer to 8 by losing. But these atoms are closer by gaining. And so with these nonmetals, like oxygen here, it's got 6 in its outer level.
1, 2, 3, 4, 5, 6.
And so it wants to gain 2 electrons. And so it's going to bond with something that can give it 2 electrons and give it 8 in its outer level.
8 electrons.
Notice still 8 protons in there. Still oxygen. Still 8 protons like always. But just a different number of 2 extra neutrons.
2 extra neutrons.
2 extra negative charges. That's why if you look at oxygen, it's in the column labeled -2.
-2. Yep.
So here's just a real quick diagram as we were finishing up of ionic bonding. Do you want to talk us through this?
So this shows our sodium atom with 1 valence electron, and it will donate to something that only needs 1 valence electron. Ideally, it can also participate in some other types of bonding, but as you see, as sodium donates 1 valence electron to chlorine, which has 7, 1, 2, 3, 4, 5, 6, 7. All right, it gains that 1 that sodium gave it, and it gains a number all the way to 8. Okay, and then sodium loses that 1, and its last energy level now contains 8.
So both of them now have 8 in their outer level.
So
they're
both
attracted
of them
like a magnet now because one of them's positive and one of them's negative.
Both of them are very happy. They have both 8 electrons in their outer level.
Happy.
Happy.
Okay, a couple of things real quick about the properties, and we're going to move through this fairly quickly here. But ionic compounds have a couple properties. Number one, they exist in a crystalline type pattern. Every ion is attracted. They're attracted to these other charges. We said the opposite charges, but because of that, it results in this 3D type pattern. And this is an example down here of NaCl, which was the ionic bond Coach Forster just walked us through.
So you have these purple sodiums.
You see the crystalline kind of the repeating type pattern. Is a characteristic of an
Everything's
ionic
hooked together
compound.
in a crystal pattern. And
properties?
yeah, well, because of that crystal pattern, they have a high melting point. So it's not easy to break apart these atoms that are very, very close to each other. So that a crystal pattern leads to very strong bonds, making it hard to break apart ionic compounds.
So it takes a lot of
high temperatures
to break these bonds.
Make them melt, right?
Okay. And so conductivity.
Mm-hmm.
We've said these are when dissolved in water, ionic compounds will conduct electricity most generally. In water, the bonds will sometimes leave. What they do is they leave a lot of those ions, mainly those negative ions, probably, to carry around those charges.
Right.
And so as those ions are broken apart and those negative charges are put into that water, it leaves an easy way to conduct that electricity.
Right, and we kind of looked at conductivity before in the metals, nonmetals, metalloids lab. So metals and nonmetals tend to have some conductivity, mainly metals. But when they come together, when they form it with a nonmetal, then they are able to still conduct electricity.
Okay, so
and here's just kind of a diagram. So we have our water molecules floating around here, and we add, for instance, table salt in our crystal pattern of table salt here. And what that water molecules tend to do is break apart this crystal pattern, right? And when we have these positives and negatives floating around in solution, it's going to be able to conduct electricity from one side of our conductivity probe to the other. And we're going to look at this in a lab as well. So we'll be able to test each one of these properties in a lab.
Well, that's it.
Yep. That's the properties of ionic compounds. And next time we're going to talk about a little bit more about ionic compounds, how to name them and everything.
All right. See you next time.